In this video, we're going to look at a more complex example of balancing equations involving molecules. And the particular reaction we're going to look at is this reaction here, the reaction between dimethylhydrazine and dinitrogen tetroxide to produce nitrogen gas, water, and carbon dioxide gas. This chemical reaction was actually the reaction used to provide the energy of lift for the moon lander to take off from the moon's surface during the Apollo 11 mission. This equation as it stands is unbalanced at the moment. We can see that on the left hand side I've got the carbon atoms inside the bracket and there's a 2 outside the bracket, indicating I've got 2 carbon atoms on the left hand side, and at the moment I've only got 1 carbon atom on the right hand side. I've got a total of 8 hydrogen atoms on the left hand side. There are 3 inside the bracket and the 2 outside the bracket indicates that there's 6 associated with the CH3 group, and then the additional 2 there is 8 hydrogen atoms on the left hand side, and at the moment I've only got 2 hydrogen atoms on the right hand side. I've got a total of 4 nitrogen atoms on the left hand side and only 2 nitrogen atoms on the right hand side, and 4 oxygen atoms on the left hand side, and a total of 3 oxygen atoms on the right hand side. So this equation is clearly unbalanced at this point in time. So you'll remember our hints for balancing equations. They're still valid here. We're going to identify any elements in the equation and we're going to leave them till last. So we can see that nitrogen here is an element and we'll leave nitrogen till last. We're going to identify atoms that appear more than once on either side. I'm going to leave them towards the end as well. And we can see that oxygen appears more than once on the right hand side of the equation. It appears in 2 substances, and we can see also that nitrogen appears in 2 substances on the left hand side. So that's another reason to leave nitrogen till the end. Identify hydrogen atoms and oxygen atoms and leave them till later, again particularly if water is involved. So we'll balance hydrogen second, and then we'll balance the carbon first, because we're going to be balancing all other atoms first, and that leaves us with balancing the carbon atoms. We've got 2 carbon atoms on the left hand side. The 1 times the 2 there gives us our 2 carbon atoms, and we've only got 1 carbon atom on the right hand side at the moment. So if I put a big 2 in front of the carbon dioxide, I now have 2 times 1 carbon atoms, and I've got 2 carbon atoms on either side of the equation now. I've got a total of 8 hydrogen atoms. That's made up of the 3 times the 2 plus this extra 2 here, so 8 hydrogen atoms on the left hand side, and as I said before, only 2 hydrogen atoms at the moment on the right hand side. So to balance that, I'm going to put a big 4 in front of the water, and that will give me my 4 times 2 hydrogen atoms, giving me 8 hydrogen atoms on the right hand side as well. Oxygen's the next element I'm going to balance. I've got 4 oxygen atoms on the left hand side, and I've got a total of 4 oxygen atoms associated with the 4 waters, plus another 4 oxygen atoms associated with the 2 carbon dioxide molecules, which gives me a total of 8 oxygen atoms on the right hand side. So to get 8 oxygen atoms on the left hand side, I'm going to put a big 2 in front of the N2O, and that gives me my 2 times 4, 8 oxygen atoms on the left hand side to match the 8 oxygen atoms on the right hand side. So lastly, I'm going to count up all my nitrogen atoms on the left hand side. I've got 2 there, and I've got another 2 times 2 there, so I've got a total of 6 nitrogen atoms. At the moment I've only got 2 nitrogen atoms on the right hand side, and I'm going to put a big 3 in front of the N2 to get my 3 times 2 is 6 nitrogen atoms on the right hand side, which matches the 6 nitrogen atoms on the left hand side. So this equation is now balanced. We've got 2 carbons on the left hand side, 2 carbons on the right hand side. We've got 8 hydrogens on the left hand side and a total of 8 hydrogens on the right hand side. I've got 8 oxygens on the left hand side and a total of 8 oxygens on the right hand side. And finally 6 nitrogens on the left hand side and 6 nitrogens on the right hand side. In the next video we will look at balancing chemical equations involving polyatomic ions.